Hello everyone, welcome to this video. In this video we shall learn how we may insert many numbers in between two numbers such that the resulting sequence is an arithmetic progression, an AP, right? So here the problem is we are given two numbers A and B. Can we insert as many numbers as we like between them to make them the resulting sequence as an arithmetic progression? So the answer is yes, that we already know. But how can we do that? So let's have a look. First of all, if we assume that the n inserted numbers, so between A and B, if we insert A1, A2, A3 up to AN, so we are calling the names of these numbers as A1, A2, A3 up to AN, right? These are the n such numbers, such that this sequence A, capital A1, capital A2 up to capital AN, and the last member is B, this is an AP, right? So here if we count that this is our first term, this is our second term, this is our third term, and similarly because second term is third term would be this fourth term, then this would be your n plus 1th term, right? And this would be your n plus 2th term, correct? In total you have n entries of AN, right? One here and one here, so in total n plus 2 terms. So you see B is your n plus 2th term. So using the formula of n plus 2th term, we know the formula for nth term. You know AN is what? It is A plus n minus 1D. Now if you wanted to write an plus 2, which is B in our case, right? So what we are doing, we are replacing this n with n plus 2. So it would be A plus, in place of n we are now writing n plus 2. So n plus 2 minus 1 times D. So this is what I have written here. B is equal to A plus n plus 2 minus 1 times D. So when you solve this thing, you would have n plus 1. Right? So when you can take this A to the left hand side, so that we would have a change in its sign. Here it is positive. When it will come back to this left hand side, we would have a negative sign over here, correct? And so the value of D that we obtained from here is B minus A upon n plus 1. This is the common difference for each of the term. Right? Now this was our AP. Now in the standard form we have our AP like this, where A is the first term, D is the common difference. So the first term is A, second term would be adding the common difference to the first term, that is A plus D, then A plus 2D, and so on, right? So when we compare the terms, our first term A is equal to this A, that is given to us, right? So the next term would be A plus D. So our A1, capital A1, that would be A plus D. So we already have the value of A with us, that is given, right? And we have evaluated the value of D here, so we can substitute this value over here, so that we would have B minus A upon n plus 1. So this is the value of A1. Now next we can again similarly calculate the value of A2. On comparing, you get the value of A2 as A plus 2D. So it is A plus 2D. Now you can substitute the value of D here. So this is your A2. In a similar manner, you can compare and calculate each of A3, A4, A5, A6, A7, A8 and so on up to AN. Right? So this is the formula in general. So in general, what would be the formula? AN would be A plus n, B minus A upon n plus 1, correct? So this would be, and let me call it AP, not AN, because this n is here. We have already used the n here to denote the number of terms, right? So if you put P is equal to 1, you would have the this value A1. If you put P is equal to 2, you would have this second value. If you put P is equal to 3, you will have the value of A3, which would be A plus 3 times of B minus A upon n plus 1, and so on. You keep on doing like this. So this is the formula here. Correct? So you can solve the questions using this formula. You can just remember this formula and then solve the questions, or I can show you other way. So this is just learning the formula and then applying it to the solutions, right? But I prefer to use a different technique to solve the questions that would be much related to the concepts of this arithmetic mean. So let me show you the one question relating to that, right? So the question is, here we need to insert 6 numbers between the number 3 and the number 24. So we have the number 3 and we have the number 24 we asked, and we wanted to write 6 numbers in between them, right? So we would wanted to calculate what is A2, A3, because this is your A1, which is nothing but A, and which is given to be 3, correct? So A2, A3, A4, A5, A6, A7, and this would be your A8. So in total for this AP, we would have 8 terms, with the first term as 3, that is known to us, right? So in the standard form, your arithmetic progression could be written in this manner, where we have A plus D, A plus 2D, and so on, right? So our arithmetic progression would become, we can substitute the value of A here, so it would be 3 plus D, 3 plus 2D, 3 plus 3D, 3 plus 4D. So I am writing whole of the terms, right? So 3 and 24 are given to us. In between, we need to write 6 terms of such kind: 1, 2, 3, 4, 5, and 6. So the first term would be 3 plus D, it would be 3 plus 2D, next would be 3 plus 3D, next would be 3 plus 4D, 3 plus 5D, and 3 plus 6D, correct? So this is our AP. Now here we would know our AP completely if we know what is the value of D here. So how do we calculate the value of D, the common difference? So in order to calculate the value of D, we will make use of this last term, right? What is the last term? It is 24, and according to the question, it is A8, the 8th term. 1, 2, 3, 4, 5, 6, 7, and 8th term, right? So we will make use of this thing over here. So we know the 8th term of the above AP is 24. If that is so, we can apply the formula of A8. It would be A plus 8 minus 1 times of D. The value of A is known to us, which is 3. 8 minus 1 is 7D, right? So what is A8? It is 24. So we will substitute the value here. So therefore 24 is equal to 3 plus 7D. So we can solve this thing over here and calculate the value of D. So the value of D comes out to be 3, correct? So this is the value of the common difference. Now we know the value of common difference. We can substitute it here in this sequence, correct? So that we would have 3. 3 plus 3 is how much? It is 6, right? 3 plus 2D is how much? It is 9. 3 plus 3D is how much? It is 12. Next would be 15. Next would be 18. Next would be 21. So our resulting arithmetic progression, it would be 3, 6, 9, 12, 15, 18, 21, and 24. So that means we have inserted 6 numbers in between 3 and 24 such that the resulting sequence becomes an arithmetic progression. So this is the way in which you can solve your questions. So I hope you understood this way of solving the questions. Moreover, you can solve this question also using this formula. You can just you know the value of B, right? The value of B in our case is 24. The value of A is 3, right? And how many terms we wanted to insert here? 6. So 6 plus 1, right? Times P, and then we have A as 3. This is the value of AP in our question. So when we solve this, it is 21 divided by 7, which is 3. So it is 3 plus 3P, correct? The value of AP. So that means our first term would be 3 plus 3 into 1, which is 6, right? Our second term A2 would be we will substitute P, the value of P here as 2. So it would be 3 plus 3 into 2. So how much it is? It is 9, right? Similarly, A3 would be 3 plus 3 times of 3, which is 9 plus 3, that is 12. Then A4, it would be 3 plus 3 times of 4. So 12 plus 3 is 15. Correct. Similarly, what would be the value of A5? Here A5 would be 3 plus 3 times of 5. So it is 3 plus 15, which is 18. Correct. And what the value of A6 would be 3 plus 3 times of 6, which is 3 plus 18, which is 21. So you see we have all the terms here. The first term was 3, the last term was 24, and in between we have 6, right? Then we have 9. Then we have 12 and 15. So 12, 15, then 18 and 21, right? So this is our resulting AP which we wanted to calculate, and this we have done by using a formula. So I hope you understood this methodology well. That is it for this video. Thank you for watching.